So what I want to talk about in this lesson is the early chemical evolution in our universe. So we want to kind of talk about the chemical evolution. So really what we're trying to understand is all of these elements here that are on the periodic table, how did they come about? And what was that process for that? So in the beginning, so if we think roughly about 13.8 billion years ago, so in the beginning there was, according to scientists and the current best explanation, we had what was known as the Big Bang. So we had the Big Bang. And during that time, so space started to expand and we started to have the early remnants of matter. And before this stage, everything was in darkness. So we can call this the dark ages. Then what started to happen is we started to get these big massive gas clouds, and we had our first elements that were formed, and they're simple elements such as hydrogen. Simple elements like hydrogen, sorry, that's helium and hydrogen. So you had these big gas clouds of hydrogen and helium. And what they started to do then, they started to come together and they started to produce, they started to kind of form into stars. So we had stars start to be formed. So our first stars. And these first stars, they were massive stars, they were huge stars, and they're generally made up of hydrogen. And what they started to do is they started to fuse together and they started to convert hydrogen into helium, and then they started to convert helium then into other elements. So what we can say then is, with these stars, we started to get the first elements. Okay, and then also with this process as well, with the formations of stars, we started to get the first light. So the first light. And these particular stars, they were massive. They were massive. And like the unit that we can use to measure these massive stars, we can say that they were 100 solar masses. So we have an M and then a circle where this kind of represents the sun. So one, if we like, one solar mass. So roughly this is the size of the sun. If we think about the sun, for example, the sun contains 99% of the elements on Earth, 99% of the mass of the universe. So if we have a look, this. So we're trying to understand what a solar mass is. So solar mass, the sun, so it's an average sized star, contains more than 99% of the mass of the solar system. So one solar mass is all the mass, let's say, that's contained within a solar system, or all the mass that's within our sun, which is a standard size system. And just to give you an idea of the size of that, so it's equal to, it's a huge number, equal to 2 multiplied by 10 to the power 30 kg. So it's a massive amount of matter. So that's one solar mass. So if we think about it, so these first stars were huge. They're about 100 times the size of our sun. And these first stars, they had a relatively short lifetime. So short lifetime. And the way to kind of understand it is, so one solar mass, for every one solar mass you have, a star roughly lasts about 10 billion years. So one solar mass. So the bigger the stars are, the shorter their lifespan. So these were big, huge stars, and they had a relatively short lifetime. Now, one solar mass, like a star, like for example the sun, our sun, has a lifespan of roughly about 10 billion years. So these had 100 times that. But again, these are relatively short lifetimes in comparison to the overall time that the universe has been around. And these guys here, so these are first generation stars. So first gen stars. And what started to happen then, so as a star goes through its life cycle, what it does is it burns up all its fuel. It starts to it burns up all its fuel, it starts to expand, and then eventually what starts to happen is it explodes in what's called a supernova. And when it explodes, basically what it does is it scatters all of its, so it takes, if we take this cloud then, so what happens is this cloud then becomes, so within the stars you have, so hydrogen being fused into helium, but then helium being fused into other heavier elements. So you get lots of other elements are being produced within the cores of these stars. And what happens eventually then when they expand and explode, the environment around them becomes enriched with everything that was part of the star, including all of these new elements. So you would have had all of these elements, heavier elements, for example, that would have enriched this big massive gas cloud. And what would have happened then is the same thing as gravity is going to start taking effect. And what you're going to do is you're going to start to get these what are known as second generation stars. So imagine this is a second generation star here. This is a second generation star here. So you get another one here, another one here. And these might be made up of different, the heavier elements. And also then within that, you're going to get these first generation stars made up of the lighter elements. So basically what you're going to get is you're going to get new elements being made by the process of fusion. So this basically when this happens, when these early stars exploded, they enriched the environment, let's say within the gas cloud. So you get these fusion elements in this cloud. And these, if you like, so these second generation stars, so these are second gen. So these second generation stars are relatively lower mass. So they have lower mass and they're roughly between 0.6 to 0.8 solar masses. So roughly around 60 to 80% of the mass of our sun. So they're much smaller. And these smaller stars, they have a much longer lifetime. So you're talking roughly between 15 to 20 billion years. So that's these second generation stars. So what starts to happen then is, you get this cycle. So you get a star formed. The star starts to fuse things and make loads of elements. Then it explodes. So you get this what's known as a supernova. And then what starts to happen is we get a gas cloud then that's enriched with all of these different elements. And then what starts to happen then is these elements come together. These heavier elements come together and you get more stars. So you get more stars like so. And then what happens is they explode. Some of these explode. So you get these supernovas. And then you get, more and more stars. So you kind of get a star. Then you get supernova explosion. Then you get some more stars. Then you get more supernovas. And then, but what's happened is as we go through this cycle, we start to get more and more elements are formed. More and more of these heavier elements are formed. And these second generation stars are also formed then as well. And they're much more stable because they've a much smaller mass. And with the formation of these heavier elements, you start to get a lot more things start to happen then as well within the universe. So you get more stars for one. So you get much more stars. You get more supernovas. Then with this as well, you also get more of all of the elements. And then what's really important then is with all of this, you get the formation of larger structures. And such as, for example, our Milky Way. So our solar system. So you start to get, as we go through this process, stars make elements, they explode, they enrich the environment around them. Those new elements then come together, make more stars, and they produce more elements. They go through supernova, they enrich the environment even more. When you start to get heavier elements, then you start to get planets and all other types of celestial bodies then start to form. So gravity basically brings all of these elements together and kind of clumps them together. So over time then you start to get more and more elements, and with more and more elements you start to get larger and more complicated structures that are formed, including planets. And then with planets then you start to get all of life, and then through evolution then you start to get all this different variety of formations being formed as well. So that's really just a quick kind of overview of like chemical evolution, let's say how, so we've gone from the start of the Big Bang, simple elements such as helium and hydrogen, we get stars formed, we get more complicated and heavier elements produced through the process of fusion, and then through a continued process of stars being formed, fusing the elements that are part of their system, making more complicated and heavier elements. Then what starts to happen is you get more and more elements formed, and with more and more elements formed, you start to get more and more complicated structures being formed as well. And we talk about this solar mass. So the solar mass basically is it's a unit that astronomers use. So one solar mass is roughly the size is the mass that's contained in our sun. And just to put that into kg, it's 2 multiplied by 10 to the power of 30 kg. And these another way also as well, if you think about in terms of lifespan, every stars that have, let's say, one solar mass would be roughly 10 billion years. So when we started off, we had these huge massive stars, the first generation stars, and they were 100, so they were 100 times the size of our current sun, but they had relatively short lifespans. So hopefully that makes sense, and we'll talk a little bit more. We'll talk a little bit more about more of this chemical enrichment process that happens in the next video. Okay, so thank you for listening.